Hello everyone, and thank you for attending today's webinar, Your Real-Time Communications Are Better Off When They Are Cloud Native, sponsored by Ribbons. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, please complete the survey that is open on your screen. The survey will only take 1 minute to complete, and your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn over the event to Light Reading's contributing analyst, Ros Brosborough. Ros?
Great. Thanks, Catherine. And thanks, everyone, for joining us today. Today, I'm joined by Brad Chalker, Senior Product Manager at Ribbon Communications, and Mark Price, Director, Product Management, Automation, and Orchestration at Ribbon. I'll start off with a short overview of what it means to be cloud native, some of the benefits of cloud native, and end with some data from an Omdia study of CSPs and their IT plans. I'll then hand it over to Brad, who will present some additional market information, including SBC adoption. Mark will talk about cloud-native operations. Then Brad will finish us up with a discussion about cloud-native SBC. We'll have a few poll questions as we go through. At the end, we'll answer audience questions. Feel free to submit them as we move through the presentation. So cloud native is a phrase that encompasses both architectural and operational aspects, and I've highlighted a few of the most important here. My comments are about cloud native in a broad sense. Brad and Mark will speak about it more specifically as it relates to RTC. In terms of architecture, one principle of cloud native design is to have functions broken up into discrete elements, often representing a single process. This is in contrast to the situation we've traditionally had in telecom, where one platform performed multiple processes. The software in cloud-native architectures is usually packaged in containers and managed using tools like Kubernetes. These are sometimes referred to as CNFs, or containerized network functions, as opposed to VNFs, or virtualized network functions, where software is packaged as virtual machines, or VMs. Lastly, declarative APIs are used to loosely couple systems. We'll see on the next slide some of the outcomes that are possible once these architectural elements are in place. From an operational standpoint, cloud-native designs come out of different approaches to development. Agile describes a software development process that uses numerous short cycles to quickly achieve desired outcomes. DevOps is shorthand for development and operations, whereby the development team and the operations team that will support the software in production work together to create that software. Continuous integration, continuous deployment, or CI/CD, describes when software is integrated and deployed on a regular cadence in increments, rather than wholesale upgrades of entire systems at the same time. The benefits of cloud native are many, and I've highlighted some of the major ones here. Because of the microservices approach, it is much easier and potentially less disruptive and risky to scale up a service. Similarly, because they are working with smaller bits of software and have more processes automated with the cloud native approach, CSPs can be much more agile than before. Flexibility is the other side of the agility coin. Again, due largely to automation, deploying software can happen much more quickly with cloud native. This automation also makes for more predictable and presumably more consistent and correct software deployment and management. The last thing I want to cover before handing over to Brad is some market data from an Omdia study. This chart shows the percent of CSPs saying that a given business challenge is very important. As you can see, right around a third of them say that embracing agile operations and methodologies, moving OSS/BSS to the cloud, and migrating data to the cloud and incorporating AI processes and operations are all very important challenges that they need to address. And here we see how cloud-native principles are impacting CSPs' IT plans. More than 35% of CSPs said that using AI and analytics to automate network operations activities, migrating OSS and BSS to the cloud, and incorporating open APIs into telco IT is very important. 35% said that end-to-end service lifecycle management and automating business processes is very important. And a little under 35% said that embracing agile principles and migrating IT systems to microservices architectures is very important. Now I'd like to turn it over to Brad, who will provide additional insights specific to market adoption of cloud-native SBCs.
Thanks, Roz. Hello, everyone. So I wanted to spend a few minutes and just talk about what some of the market forecast data shows for adoption of cloud-native, moving applications into cloud-native environments. Kubernetes and containers are essentially defined within 5G architectures. And, as everyone probably knows, containers are widely used in non-real-time applications. Most of the World Wide Web services across just about every industry, people are using containers. A container is a lightweight, standalone software package, includes the application code and all its dependencies. And there's a lot of benefits that can be realized in terms of OpEx and automation when you move to this kind of environment. And we're going to talk a lot about that concept of optimizing your OpEx as well as automation as we go through this presentation. So Exact Ventures shows a fairly significant market shift in the adoption of the SBC into cloud-native environments. Where 2021 kind of becomes the turning point, you see, their forecast is a 50% increase in 22, and then a pretty dramatic increase over the next 3 years. And I think the message here is that, we feel, and certainly Ribbon is taking this approach in terms of architecting our products, for telcos to compete in the future. And in a lot of cases, we're seeing partnering with hyperscalers, partnerships between AT&T and Microsoft and BT and Microsoft. Now is the time to learn the technology and its benefits, really to start planning for the migration. Ribbon has an initiative called Telco Cloud. Internally, Telco Cloud has been a bit of a buzzword out there, but we have an internal initiative to facilitate the market adoption, not only for the SBC, but all of our products across our entire portfolio. And then just, to kind of back up the market data and back up some of the stuff we talked about, you have a pretty significant shift with certainly 5G has moved to, Kubernetes and container platforms and cloud-native platforms. But we're seeing, all of the service provider customers, certainly that we work with, start to talk about and figure out ways to start moving their applications to cloud-native. So I'll hand it over to Roz for the first poll question.
Sorry about that, had myself on mute. Thanks, Brad. Let's take a look at that first poll question. So we'd like to ask the audience, what are your cloud-native adoption plans for real-time communications workloads? Is it something that's already being done? Is it something that is planned to be done between now and the end of 2022? Is it that it will be done no sooner than 2023, or perhaps you have no current plans? And so we'll give everybody a few seconds to answer this question, and I will ask Brad while we wait what your experience with talking with your customers suggests is going to be the most common time frame for going cloud native for RTC.
Right. So we have a few early adopters that are looking to start deploying in early 2022 to mid 2022. I would say the majority, it's serious discussions about starting to plan, wanting to make sure what our plans are, wanting to make sure what the other vendors with their real-time communications plans are, so they can start making that shift towards the end of 22 or early 23. But we do have a few early adopters that are planning for early to mid 2022.
Okay, that'll be interesting. I don't have a good sense. It always seems to be taking longer than we expect. It seems like every time I did a survey, it was always, 2 years from now was always the answer. But we'll see. I've been watching the poll numbers come in. I'll give folks another second.
This is a big shift, right? This is a big shift. This is a big shift in as you're going to see from some of the presentation we're going to have today. It's a big shift in philosophy for operations and things like that. So,
yeah, absolutely. All right. Well, it's more than just a notion. Let's take a look and see where we're at. All right. Wow. A third of respondents said it's already being done. That's actually higher than I was expecting. Another third between now and the end of 2022. But you see a good quarter of them still have no current plans, which is clearly why they're on this webinar, to learn more about it. So that looks like opportunity to me, Brad.
Yep. Thanks.
All right. I'll hand it back over to you now.
Okay. All right. So what I want to do now for the next few minutes is just talk about kind of what we see with cloud native and the adoption of it with the SBCs. This is a fairly obvious slide. You start with appliances, you kind of move into virtualization, and as part of that operations, this middle pink boxes, when you have appliances, things are mostly MOPS, which are just, written down procedures and scripts. When you move into virtualization, most of the time what we see is customers start to think about adding a little bit of automation with Ansible in order to automate maybe configuration or automate the instantiation. Then as you move into more of a VNF environment, and you can put public cloud, OpenStack, those types of platforms in that category. Then you get more into, certainly with the public cloud environment, you get much more into using things like Terraform for orchestration, lifecycle management, as well as Ansible. And then when you get to cloud native on the far right, that's when you start to use Kubernetes for orchestration, Helm charts for the instantiation templates, and then Ansible. And then CI/CD becomes a big part of this cloud native environment, and certainly Mark Price is going to talk to you a little bit about CI/CD. But as you go from left to right, there are increased levels of DevOps that are required really to recognize the cost savings and OpEx that you need, that should be part of the business justification to go, through this process of virtualization, VNFs, and eventually CNFs. And OpEx savings can be a direct result of increased DevOps in your environments. Service providers globally, certainly as from that poll, we've got all but 25% looking at plans to how to run their real-time applications in cloud-native environments. And 5G is a big driver for this. Dish announced putting their whole 5G infrastructure into AWS. But you have to be able to deliver services with new levels of agility and scalability. And one of the things that Ribbon has had to deal with when it comes to real-time communications is, the session border controller is a bit of a unique workload when it comes to virtualization. It's pretty easy to build a session border controller when it runs in an appliance that's got dedicated CPU, dedicated memory, dedicated architecture. But running it in a virtualized environment creates a fair number of challenges when it comes to protecting quality of service of voice packets and making sure that KPIs are satisfactory for your customers. And so it takes a lot of expertise to figure out how to do this, and it's something that Ribbon prides themselves in how to move real-time workloads into these non-dedicated environments. And then scaling a cloud-native SBC is always dependent on how it's deployed, orchestrated, and managed. And you have to make sure you have specific implementations of automation in place to do that. One of the things we're going to get into in the next section deals with, what are the real benefits of making an SBC cloud native. And the whole idea behind, and even with technologies like OpenStack in the private data center, the idea is to try to operate the telco workload like an IT workload. So you create more of an assembly line for lifecycle management versus having, operational silos. You incorporate it into your normal DevOps cycles and engineer it once, common set of reusable building blocks, and then you're able to replace all of those MOPs, those method of procedures. You replace MOPs with personnel that can use things like Jenkins, Helm charts, Ansible Tower, etc. And these are the tools that you need to, turn the realization of automation and DevOps into true OpEx savings. Just decomposing an SBC and putting it into a virtual machine or, putting it into a Kubernetes pod, that's not going to be the thing that drives your OpEx or CapEx reduction. And it's not even going to change the SBC functionality necessarily. You have to invest in the automation, invest in the CI/CD, and invest in the DevOps. And this, I'm sure many of you have seen this Dilbert cartoon, but it really does capture the essence of what we're trying to say. Moving to containers doesn't magically give you the results you need without making the investment in automation, DevOps, and commitment to a fundamental change in how you do operational procedures and the philosophies. So with that, I think I'm going to hand it over to Mark to talk about some of the automation. Actually, sorry, I think we have a poll question. Right, Ross? Yeah.
Yep, we got a quick poll question before we'll turn it over to Mark to talk about automation. Thanks, Brad. So let's take a look at this next one. So question for the audience is, what are your plans to support automation in the following domains? For lifecycle management, instantiate, terminate, upgrade, and scale. Is it application workload provisioning, day one provisioning, day two, and ongoing service? And then testing, both functional end-to-end or acceptance testing. So again, I will give folks a second to think about this and answer this question. I don't know whether Brad and or Mark can make a comment on perhaps which do you think folks are going to be looking at first in terms of automating in those three different domains.
Sure, thanks, Russ. I find, we see most people starting with lifecycle management because the tools are, there's a lot of tools out there that can do that today. The domain is well known. And then I think you see people, although they'd love to move to test, it becomes hard to do without provisioning. It becomes a journey, ultimately, to get to you mentioned CI/CD is the end game. So that's what I'm expecting. We'll see what we see.
The lifecycle management, and I would assume I'm hoping that you'll talk a little bit too about which gets you kind of the biggest bang for your buck in terms of automating, in terms of what the biggest effort is today and which is going to show the biggest improvement once you start automating. Let's see, I've got some answers in. Let me give folks another second. All right, let's go ahead and take a look and see where folks are at.
There we go.
Well, look at that. It's the exact opposite of what you thought. Testing, half of them for testing, and lifecycle management was the lowest. Very interesting.
Yeah, and I think that reflects your question about the value. I mean, the value really is on the testing side. And the journey, though, is easier to start with lifecycle management, I would say, just because of Kubernetes and the tool system out there. But obviously, the value is on testing, so that makes sense as to why people are focusing on testing. But this gives us a good opportunity to talk about these domains moving forward.
All right.
Hey, Mark, real quick. Mark, will you turn up your mic a little, please?
Sure. I'm not sure. Here, let me try to get a little closer. I'm not sure. How's that?
Oh, that's better.
Okay. All right.
All right. Well, I will hand the controls back over to you, Mark.
All right. Thank you. So as we talked about, this is a discussion about operations in the world of cloud native. So Brad's going to continue discussion about architecture. And there's a lot of discussions about architecture, Canary upgrades, and microservices stuff. But ultimately, we need to value the OpEx savings out of the operational changes that occur when we move to cloud native. And at Ribbon, we are a CNF provider. And what is our role in that? And we see our role as delivering the technology with our CNFs that enable automation. And there are a lot of different automation environments out there. There are full CI/CD pipelines. There's orchestrators available from different companies. There's just the GitOps approach of putting in like a GitLab or something along those lines. And then there's the end portals, the user portals as well. All of these require automation. And our goal is to deliver the tools, and CNF and VNF vendors in general, the goal should be to deliver the tools with our applications that make that integration exercise easy and eliminate friction. So before we start, let's just a little step back as to what's driving. We take automation for granted. We should do it. Let's just kind of step back and talk about why we're doing this. What are the drivers behind it? The move to CNF introduces complexity. There's value with that complexity, but there is complexity. We've decomposed further into microservices. We're transitioning from very large network functions or network elements into smaller CNFs, and we've introduced horizontal scaling, sort of on-demand scaling. All of this introduces some level of complexity from an operational point of view. And to tackle that, you really do need automation. The reduced OpEx. And the reduced OpEx is more than just taking what would take 2 hours to do manually to reduce it to 2 minutes to do automatically. It's really the bigger picture of reducing errors, eliminating configuration drift. With the automation tools, you have a source of truth external to the network function that defines the configuration, that defines the deployment. That leads to faster troubleshooting. So it's really the additional benefits over and above just the time that automation saves you that really is the OpEx saver and the total cost of ownership reduction. And then ultimately getting functionality into deployment faster, realizing that value, having the end customer realize that value faster. That can only be done through fully automating from start to finish so that testing and deployments can happen quickly and more frequently. So the ultimate goal is to get to a full CI/CD environment. But to do that, we really need all of those operational interfaces. We have the pull question. But ultimately, you need automated lifecycle management, you need automated provisioning, and you need automated tests to really drive full CI/CD. Now, CI/CD in the world of telco and the CSP space we live in, it's a little different than the CI/CD you might Google in that Ribbon has a CI/CD pipeline internally in which we code and we build and we test and ultimately deliver software to our end customer, the CSPs. But enabling a full automation environment in our customer environment, in the CSP environment, is really the goal here. Because those deliverables that come from Ribbon or from the CNF vendor, they're air-gapped and often generic in nature, and they require customization for the end environment. The tests tend to be specific to the environment they're going to be deployed in. And ultimately, if we can automate that, CSP can automate that, we get the results. We, the CNF vendor, can get the results back. We can run it through our test environment and produce a new artifact, a new build, and really having these two wheels sort of spin in lockstep is really only possible by automating all operational interfaces. And this is our goal, is to get to this environment. And different CSPs are on different steps in this journey. All right, so how do we do that? So there is many different service orchestrators out there. Some call them domain orchestrators. There's orchestrators that sit on top of orchestrators. There are CI/CD pipelines that we just talked about. There's sort of just a basic GitOps environment that is quite popular, and end user portals. How can we make a deliverable as a CNF vendor that fits into all of these? So the answer really is by providing automation technology that hides the complexity of our CNF with a simple declarative API. That is easy, very low friction to implement or integrate into any automation environment. So that we believe is the key to enabling and unlocking all of the automation and operational benefits of cloud native. So to do that again, and we talk about breaking this down, and I'll show an example in a second here. We break this down into 4 domains. Infrastructure, what needs to be, can we automate the environment that is required before we instantiate, before we lifecycle manage? Then there's, so I would call it the obvious, the lifecycle management, automation, the ability to instantiate, upgrade, scale, and such. With containers and CNFs, we're kind of fortunate in that there's really sort of one game in town, and that's Kubernetes over in the virtual machine space. Ribbon has invested in and created some tools outside of, say, Heat and CloudFormation and some of the industry standard tools to really automate our products and VMs. But fortunately, today's conversation with Kubernetes containers and CNFs, Kubernetes is the engine there. And then automating provisioning. You need to automate provisioning before necessarily you could automate test. And so getting all of these domains automated is really the key in where we're moving towards. So what does that look like? So I just read this because I don't think I can paraphrase it any better. The declarative operations eliminate the friction for integration into automation environments and providing a simple command line option to start the automation journey. So by declaring in a file your intent, it's providing just a simple command line to say, take this file, give it to the automation engine, and make it so. We can stand up infrastructure. We can lifecycle manage a CNF. We can automate provisioning. I've put some examples on the right-hand side, the left-hand side, such as deleting trunks or adding users or whatever it might be. And then the same with test. Now, test is a little harder to do with this approach because the test tools are diverse, but just simply providing some level of acceptance test that is file-driven with some scaffolding around it to push that testing is feasible. So this is the methodology that we believe will enable the many automation environments that are out there today. So in the SBC specifically, the SBC CNF in containers, we've approached and used the following tools. We're using Terraform to stand up a Kubernetes environment in a public cloud, if required. Again, optional. You can always use the tools that are available from the public cloud to manage that Kubernetes cluster. But having something out of the box from the CNF vendor ourselves gets you going faster. Then, of course, Kubernetes for lifecycle management and the delivery of Helm charts. And for provisioning, we're relying on Ansible. Ansible as a tool, when Ansible playbooks are written, I would say, well, they are declaratively driven. You can put your definition of all the provisioning you'd like. Ansible playbook can apply that. And then test the same thing, defining the tests, such as acceptance tests in a file and providing it to Ansible to drive the underlying test environment is also how we want to, how we're approaching this so that we can enable these automation environments or simply a command line just to initiate a playbook. So that's an overview, I guess, of automation and operations in a cloud-native environment. I'll pass this back to Brad at this point to go into the architecture.
All right, thanks, Mark. All right, now I'd like to talk about the SBC architecture and really in the context of what are the architectural pieces that need to be implemented in an SBC to utilize the things that Mark just talked about. How do you have to change the architecture of the SBC, not only to put it in a container, and make it more microservices based, but to leverage a lot of the common cloud platform services and leverage Kubernetes, and then also be able to take advantage of all of the automation with the CI/CD pipelines and orchestrators and DevOps and GitOps and Jenkins and all these tools that are out there to help you do automation. How can the SBC be architected in a way to take advantage of all that? So we start out with some basic architecture principles that are needed. Certainly, you have to take the SBC and the pieces of the SBC and the different subsystems and move them into an architecture that looks more like microservices, and backwards compatible APIs so that you can interwork with systems, independent lifecycle management of each service. So if you're going to break the SBC up into what you might call a worker module, a signaling module, an automation module, an observability module, you have to have independent lifecycle management of each one of these services. One of the core concepts of a cloud-native environment is that you separate logic and state, so you have stateless workers, and then they all access a shared state database. This is kind of inherent to the cloud-native architecture, but it also gives us a lot of advantages in some of the public cloud environments where things like active standby high availability and performance and scalability of an individual virtual machine are not quite up to the same level as they are in a private environment. And so separating the logic and the state and using shared state databases allows you to do things like active-active workers and scaling, and gives you kind of a universal way to do high availability and scaling, regardless of whether it's public cloud or private cloud. In order to facilitate the independent lifecycle management of services and kind of follow the cloud-native concepts of upgrades, Canary upgrades within each microservice, the SBC has to be broken up in such a way that you can apply those, use the Canary upgrade load balancer, and then provide those incremental upgrades, utilizing some of the automation for automated testing when you do an upgrade of an individual pod or instance, making sure that it's stable, getting metrics back to make sure you can then go on to the next and upgrade each one down the line. And then you have to integrate with the host cloud platform services. There's an infinite amount of tools and applications out there for things like monitoring and logging, service meshes, and open telemetry type applications like Datadog and Splunk, and even to go as far to say integrate with customer specific telemetry environments, right? If a customer has a specific application that needs to receive metrics, then we have open APIs that allow you to build to that. Monitoring and logging, receiving metrics, pushing metrics around the system becomes very, very critical in the world of automation and the ability to know what's going on in the system. And then lastly, we design it to leverage Kubernetes and the orchestration capabilities. this opens up a bit of a new world for real-time communications applications like the SBC, because now, in theory, I can, build it once and then deploy it in any environment. For example, the idea being the Kubernetes environment in a private cloud with Red Hat OpenShift, I should be able to take that same application without any changes, put it into a public cloud environment that's using Kubernetes, right? And not have to do a lot of redesign on the platform layer and design to specific machine instances and things like that. So it gives us a lot of capabilities to kind of normalize the playing field and how you deploy the SBC. But something like Kubernetes also allows you to do the rolling updates, recovery, and then package with Helm to make sure you can do instantiation and get the right configuration for the SBC when it's deployed. So if we look just quickly on kind of a very high level view of what Ribbon is doing with the SBC to re-architect for these kinds of cloud native environments. We've essentially broken the SBC into fundamental components for processing the signaling, media, and state. So we have an active standby SIP load balancer that sits in the kind of at the edge of the architecture and provides signaling distribution to what we call workers, and these workers are processing media essentially for all of the calls and sessions coming in. And then those workers use a shared signaling state database in order to facilitate things like active-active failover, moving sessions in the case of a failure from one worker pod to the other. And then this architecture also facilitates horizontal autoscaling of the workers themselves. So you can have as small a footprint or as large a footprint as you want based on metrics that you want to, and parameters, how you want to allow the SBC to scale. Facilitates rolling and Canary upgrades, active-active HA for session preservation. And then to the right, a lot of focus on standard and open interfaces for telemetry and operations and maintenance operations. So you logs, metrics, and traces to things like Prometheus servers, Prometheus tracer backends, open telemetry backends. And again, one of those boxes on the right could be a customer-specific environment for receiving metrics and receiving logs and telemetry data. And so you also want to take advantage of the CI/CD pipeline and lifecycle management. So you could, the Terraform on the top, you could use Terraform to completely prepare the platform. Maybe you're going into an environment where the platform is already sitting there, and so that Terraform piece wouldn't apply. But you could use Terraform to come in and completely prepare the platform environment. Helm charts to specify the deployment characteristics, and then a CI/CD pipeline to provide the automation server, like Jenkins, in order to pull Helm charts and container images, and then use that to build out the SBC workers and SLBs in an automated way. And again, provide integration with platform monitoring, things like CloudWatch if you're in AWS, or any other environment where you want to monitor the status and health of the SBC. So this is a very high-level example, but one of the things that is inherent with cloud native are things like Canary upgrades and rolling upgrades and Canary upgrades, so you can push out new releases into the network in a safe and reliable manner and automate it so you don't have to have someone sitting at a terminal, monitoring and managing every single node that gets upgraded. So if I have, SBC workers, and these are the same workers that I showed in the architecture slide, you would instantiate, one of the workers with your with your upgraded version, and then provide the automation to only send a limited portion of the new call, a limited portion of any new calls to that SBC. So for example, 3%. You send 3% to that new worker, you monitor it for a while, and after some configurable period, you analyze all the logs and statistics. If there aren't any anomalies detected and everything looks good, traffic is good, then you go ahead and resume the SBC for worker 1, and then repeat the process for worker 2. And so you just step through this with each SBC, group of pods, and then you go to the next one, the next SBC in the network, and do the same thing. And again, this is all, all should be automated with somebody just monitoring results instead of someone having to actually, sit there and wait for the upgrades to happen. And then as the upgrade completes, you remove the prior versions, and you've got, both of those SBC workers upgraded. And this is a bit of a different upgrade philosophy than what many are used to. The whole idea of a live software upgrade where you take a running SBC and a standby SBC, you upgrade the standby, do a switch over, and then go upgrade, the new standby. This is more of a replacement model versus an upgrade model, where you're actually adding in a new instance, a new SBC worker, moving traffic to it, drying up the old one, and then deleting the old one. And this is a bit of a philosophy change for a lot of the service providers, certainly that we talk to get out of that mindset of everything has to be, upgraded in place, and having a few additional resources in the environment to use these replacement models. But at the end of the day, doing this in an automation-driven model, you're going to reduce time, reduce errors, as Mark mentioned. You're trying to reduce errors. You're trying to make sure you're utilizing resources. And then obviously, if there's a problem, then upgrades could be reverted if anomalies are detected in some period of time. You could revert back to the old version. So this is the idea, and these are the concepts that we're building to. And then autoscaling. This is an area that is at times can be a philosophical discussion with service providers. I tend to see that a lot of service providers want autoscaling. They want it to just scale on its own and contract on its own. What happens a lot of times in reality is the larger service providers aren't willing to give up that much control into the network. But we are starting to see more and more of this, and building in the tools to allow this and make sure you have control over the metrics and can utilize this technology to your benefit. But the idea is you have a couple of workers, you watch the metrics, and the metrics could be concurrent sessions, could be CPU utilization, congestion metrics, could be a lot of metrics you choose to watch using a ribbon horizontal pod autoscaler. These metrics then would trigger the instantiation of a new instance, grabs its, gets instantiated, grabs its configuration, runs through a quick test cycle, and it's now added to the cluster and becomes part of the cluster and reporting back metrics. And similarly, if you have certain time of day metrics, or you want to see the system scale in, if you're using public cloud, for example, and you want to save money at off-peak periods of the day, then the SBC, the reverse could happen, where you could monitor metrics, put one of the SBCs in dry up or one of the SBC workers in dry up, and when calls are gone, you terminate that instance, and now you're back down to 2. So as I mentioned, this is something that is being built into, it should be built into cloud native architectures. Cloud native defines ways to do elasticity and auto scaling, and so this will be implemented. So I'd just like to wrap up and leave a few minutes for questions. We're seeing communication service providers either move or planning to move to adopt cloud native architectures. Ribbon does have a telco cloud initiative designed to help service providers move their applications to cloud or cloud native platforms. As you hopefully saw from Mark's section, we are spending a lot of cycles and investing heavily in automation and lifecycle management. We want our customers to succeed, and so we feel that the automation piece of a cloud native architecture is really important to achieve OpEx savings. Certainly proper design considerations for real-time communications is critical. We have a number of tools available to make sure that when you provision an instance, for example, in any kind of virtual environment, regardless of whether it's in a hypervisor, in a VNF or CNF, that the resources are assigned properly and provisioned properly for the scale. And the goal is always to be able to achieve the same scale and functionality achieved with non-cloud native platforms. Clear back to the appliance model, right? We want to, our goal is always to be able to scale any virtual application or any software-based SBC to the same levels that you can scale hardware. And so the only way to realize a true benefit of cloud native is to invest in automation and DevOps in the operational environment. And so with that, I think, Roz, do we open it up for questions now?
Yes, we can. So thank you for your comments, both you and Mark, and folks online. If you've got any questions, please submit them in the Q&A section on the console. We have a few already in here, so let me take a look and see here. Okay, first question. What do you see regarding the split between customers moving to cloud native and private cloud environments versus using the public cloud providers?
Yeah, so many times it depends on what you're trying to achieve. What I see with public cloud more often are customers or service providers who need to deploy into a region of the world where they don't have a data center footprint already. And so you use public cloud as a way to reduce the investment to build new services into a region of the world where you don't want to invest in a data center, or don't want to invest, or you want to try to save money to get into that region of the world. We also, as I mentioned before, we're seeing alliances formed and partnerships formed between some of the big service providers and the public cloud hyperscalers. BT and Microsoft, AT&T and Microsoft. These are a Dish and AWS. I mean, these are large-scale deals of moving these services into the public cloud environment. So I see, it depends on where you're at in your evolution of moving into these environments, and some service providers just don't feel comfortable moving everything into public cloud yet, and some are ready to take the leap. So it varies.
All right, thanks for that. Let's see, next question. It looks like you have made some specific choices for CNF automation, such as Terraform and Ansible. Can you provide more information on why you chose these technologies?
Sure, I can take that one. So
Okay.
we chose this technology because of the rich ecosystem out there. They're supported in the open source community is large, but more importantly, they apply the techniques we wanted to leverage, which was the declarative approach. Terraform specifically, obviously Kubernetes, but even Ansible used correctly, so to speak, actually uses this declarative approach. So we could build on a rich ecosystem as well as leverage those tools which implemented the declarative approach well.
Okay, thanks for that. Little different question here. Can you provide an example of how you would integrate into a specific automation environment?
Sure, I can take that. Examples are always good. So probably the simplest is just to build on that GitOps approach, which becoming popular as part of Kubernetes. But it's an approach that can be leveraged for provisioning and other areas as well, where you're using your Git environment, where you're managing files as code, and the process in terms of reviews and such there. But once there's a consensus, obviously, on the file itself, the contents of the file, actually checking that file in or updating that file actually kicks off the instantiation or kicks off the automation. So it becomes quite easy to basically tie your automation to managing the files. And that's what, that's sort of one of the more simple way to enable automation with files.
Okay, thank you. Let's see. Okay, this is a kind of taking another different slant on this. Can you get CapEx reduction by moving to cloud native? We spoke a lot about the operational side, but can you get CapEx reductions as well by going to cloud native?
Yeah, I can take that. So CapEx reductions typically come when you move from private cloud to public cloud. The hyperscalers like AWS, for example, they have a number of tools and calculators that can tell you, if you plug in how much you're spending each year on servers, how much you're spending on personnel, how much you're spending on power and heating and cooling, not heating. They can give you a calculation on what your ROI would be for moving all of that into public cloud. But I think you're not necessarily going to see CapEx reductions from the technology that you implement in the platform, right? I'm not probably going to see, I wouldn't see a scenario where you'd necessarily see a CapEx reduction going from, a virtualized, kind of siloed SBC running in VMware or KVM and see necessarily a CapEx reduction when moving that to a container-based architecture with Kubernetes. But you will certainly see a reduction in OpEx if you can automate the deployment, configuration, management, CI/CD test of that SBC in that environment.
Okay, thank you. Want to make a quick reminder to folks on the call to please take a minute to answer the survey. That should be popping up. If it's not already there, it should be popping up soon. We've got a couple minutes left. Don't see anything new in here. So maybe throw it over to Brad or Mark to see if you had any final thoughts while we give folks a chance to put a last minute question in. Or we pretty much covered things.
I think we've covered most of it at this point.
Yeah,
okay.
I think I'm good. Thank you.
All right. Well, then we will go ahead and wrap this up. So I'd like to say thank you to Brad and Mark both, and thank you for everybody for joining us today. Hope it's been a good use of your time and informative, and we hope to see you on a future Light Reading webinar. Have a good day, everybody.
Thank you.